The whole purpose of computer programming is to automate tasks that would be really boring or take a long time for people to do. So it would not make a lot of sense if programmers had to sit there and program the same lines of code over and over. And that's what loops are for in programming. A loop is just a simple way to tell the computer to keep running one or two or however many lines of code you want, to keep running them over and over. So in this lesson, we're going to go over two basic kinds of loops. And this first one is called a for loop. A for loop in Java looks just like you see it here. Up here you can see that there's really three main parts. There's the code that goes inside the for loop. There are the instructions that tell the for loop how many times to run. And then there's this first word, for, that just tells it that it's a for loop. And this might look really confusing at first, but it's actually not that confusing. And if we take a look at this diagram, it'll help us understand a little bit more what each of these parts means. So there's really three parts. They're each separated by these semicolons. And the first part just tells the loop where to start. So the loop keeps track of where it is with a little variable. In this case, I named the variable I. That's a common name for a variable inside of the for loop. And I create this variable I. It's an integer, and I start it at 0. But you could start it at any number that you want. This next part in green here tells the computer when to keep running the loop. As long as I is under 10, it'll keep running the code inside the loop. And then this last part here says every time the loop runs, increment I or add to I 1. So this plus plus just means add 1 to I. And you could also use minus minus and it would subtract 1 from I. Or you can use plus equals and then a number afterwards like plus equals 3 and it will add 3 to I. So it's really not that complicated, and once you understand those three parts, you can change what goes inside the code and you can change how many times it runs. So let's try an exercise down here that is kind of similar to this. Now this will print out every number from 1 to 10, or rather it'll print out every number from 0 to 9 because it starts at 0 and it stops before it gets to 10. We're going to do something similar, but we need to print out the numbers from 5 to 21. And specifically, we have to print out every other number. So starting at 5, then going to 7, then to 9. So let's jump over to Eclipse here, and we'll see what that would look like in an actual program. So let's start fresh. The first thing to do to write our for loop is we have to start by telling Java that it's a for loop. And then all of the parameters, all of the information about how many times the for loop will run, go inside these parentheses here. We need to declare a variable, an integer, that we can use to count during the for loop. And this time I'm going to name it j. And we want it to start at 5. So we say j equals 5. That's the first part. Now we type a semicolon and go on to the next part. The next part tells us how long the loop is going to run for. So we need to say while j is less than, and let's go check the output real quick. We have to make it run until it hits 21, and it has to hit 21 and then not go beyond that. So we're going to say while it's less than 22, because if we said 21, then as soon as it gets to 21, it would stop without printing 21. And now that's the second part. It'll keep running as long as it's less than 22. And the third part, remember, will tell us how much to increment or how much to add to our loop variable every time it runs. So in this case, we want to print out every other number, so we want to add 2. So we can use j plus equals 2. And that will add 2 to the variable j every time it runs. Now after this line, we have to write an opening bracket, push enter, and Eclipse puts in a closing bracket for us. And then we just need to write a print statement that will print the variable j every time the loop is run. System.out.println j. So let's try this and see how we did. And we did exactly what we wanted to. We have every other number from 5 to 21. Now if you want, you can pause the video here and try messing with some of these variables right here, these parameters, and see if you can get the for loop to print out different ranges of numbers. Let's go back and look at the next topic. The next topic talks about while loops. And a while loop it does essentially the same thing as a for loop, but instead of running for a certain number of times, it runs while a condition is true. So the for loop will run specifically from the first number to the last number, and it'll increment a certain number of times in between that. But let's say that you wanted to keep asking a user a question until they got it right. There's no way to know how many times you need to run it for. You just need to keep running it until they have it right. And that's where a while loop comes in. So right here, the syntax for a for loop is very similar, except instead of a for at the beginning, it's a while. Let's copy and put this into Eclipse so that we can mess around with it a little bit. So you start out by saying while, and inside you put a condition. In this case, I just wrote true. When I run this, it's going to keep running this loop forever because the condition true will always be true. Also, if I just write false, the condition false will always be false. So I can put in any condition in here. One example that I could use is in a similar way to the for loop is I could say while a variable I is less than 10, keep running. And then I just have to change this around a little bit. I'd have to say outside of the loop, I'd have to declare and initialize a variable I. And then inside the loop, I'd have to increment I, just like I did in the for loop. And this will run kind of the same way the for loop did. But this is also useful if you want to check another condition. Like I said, if you're checking whether the user got the answer correct, you could say while answer does not equal 4. Let's say it's a number guessing game. And I haven't declared the variable answer here, and so obviously it's going to give me an error. But in this case, inside here, you could put code that asks the user to keep guessing a number. And as long as the answer doesn't equal 4, then it will keep running the loop again. And as soon as it equals 4, it'll stop the loop. So those are the two basic kinds of loops. Now, really quick, before we move on to the final activity, I will mention one more thing about for loops. Let me just copy this for loop in here so that I can change it a little bit. So the for loop we made starts at 0, or the one we made actually started at 5 and it went up to 21. And it increased by 2 every time. There we go, that's the code we had up before. But we don't have to start at 5 and go up from 5. If we wanted to, we could do this all backwards. We could start at 21 and we could go we can switch this around. Instead of saying while I is less than, we could say while I is greater than. And we could switch this to a 4 so that it'll count down right until it gets down to 4. And then right here, instead of incrementing, we could decrement. We could say I minus equals 2. And we basically reversed everything. It's going to start at 21 and it's going to reverse from 21 down. So here we have it counting 21, 19, 17. And this is great if you want to count down for any reason. For instance, if you're trying to go through a list and delete things out of that list, if you start at the beginning and start deleting, every time you delete something, everything else will slide down and you're changing the size of your list. So it's really helpful to start at the end of a list and delete things and keep moving backwards so that you're not affecting the things ahead of you as you're moving through the list. That's just one example of when you'd want to use kind of a modified for loop like this. Now let's go back and look at our final activity here. This final activity asks us to write a program that will practice using while loops. So our program is going to start by printing heating up, and it's going to turn both heaters on to 80% power. And then while they're heating up, every second it's going to check and see if they've hit 32 degrees Celsius. And as soon as they do, it should print both heaters have reached 32 degrees Celsius, and then it should turn off. So let's look at how we could do this. Here's an example of the output. Let's look at how we could do this in Eclipse. First, we'll start by importing the JTC Lab library. And of course, I shouldn't capitalize these. And then next we'll have to create our JTC Lab object. And we need to start by turning both heaters onto 80% power. So to do that, we can use my lab dot q1 80. And that will set heater 1 to 80% power. Oh, I have a typo in lab there. That will set heater 1 to 80% power, and we can use this same command for heater 2 with Q2. Now both heaters are powered on to 80. Now we need to keep checking the temperature of each of those heaters. So we're going to have a while loop. And inside this while loop, we need to check a condition. And the condition that we're checking is that both heaters have reached 32 degrees Celsius. And if not, it'll keep running. So we need to say, while both heaters are not 32 degrees Celsius, then keep checking. So right here, I'm going to create two variables outside the loop, temp1 and temp2. And I'm going to set temp1 equal to the temperature of temperature 1. So I can do mylab.t1, and I need to tell it that it's a double variable. Mylab or temp1 equals mylab.t1. And I can do the same thing to check the temperature of the second thermometer. Now the condition that we're going to check is that both of these are greater than 32. So to check just whether one is greater than 32, I could say temp1 is greater than 32. But I need to check both, so if you remember our operators lesson, we can use this AND symbol, and it'll say, well, temp1 is greater than 32, and temp2 is greater than 32. Keep running the loop. And once again, we're checking, we want to keep running the loop while it's not greater than 32, while neither of them is greater than 32. And so we could switch these around and say, while temp1 is less than 32 or temp2 is less than 32. Or another way to do this is we could say while not temp1 is greater than 32 and temp2 is greater than 32. That means if even one of those temperatures is less than 32, then this condition will be false and it will keep running. Or rather, this condition will be true because we have the not sign before it. While not, temp1 is greater than 32 and temp2 is greater than 32. And then the last thing we need to do is keep checking. So we need to copy these in here to keep setting the variables equal to the current temperatures every single time it runs. And then because we already declared both these variables, we don't need to say that it's a double. And then every time we check, we don't want to constantly be checking, so we're going to wait 1 second. Right here it asks that we check every second. So we can do that with the wait statement. Now remember, when we use the wait statement in Java, the thread.sleep, we have to put it in a try catch. So that looks like this. And that will wait 1 second. And then after this, it asks us to print both heaters have reached 32 degrees Celsius and turning off. So we can copy this prompt in. And then to disconnect and turn off the heaters, we can use mylab.close. So let's see if this works so far. We'll click run. We've connected successfully. And one thing that we forgot to add, I'm going to stop this a little bit early, is before they heat it up, we're supposed to print system.out.println. We're supposed to say that the heaters are heating up so that we know that the program is working and not just frozen. There, let's try running that one more time. And they're heating up. I'm going to pause the video really quick and I'll come back as soon as they've stopped heating up and we'll see if it worked. Okay, so you can see that it did indeed work. After about 30 or 40 seconds, they both reached 32 degrees Celsius, and you can see the output said both heaters have reached 32 degrees Celsius, turning off, and it disconnected from the temperature control lab. So that's our overview of loops, the two main kind of loops that we'll be using in this course, while loops and for loops. If you want to experiment around with both of these kinds of loops, feel free to copy in these samples into Eclipse and try playing around with them. And I'll see you in the next lesson.